Molds are fabricated on alumina substrates in a 3-layer process. First, the substrates are cleaned, and then an anti-reflective layer is placed on, and then 2 layers of SU8. The blank substrates are cleaned first using a methanol wash here, and then an isopropyl alcohol wash IPA here. The anti-reflective coating is spin coated onto the substrate and then placed on a hot plate to allow drying. After the first layer of SU8 is spin coated onto the substrate, it is completely cured with UV radiation, creating just a base layer underneath what will be our mold layer. The second layer, the mold layer of SU8, is then spin coated on top of the base layer that we just put on. And then now this layer is exposed through a mask. You can see we are just aligning the bars to the middle of the substrate and exposing the top layer through the mask, creating our mold arrays. And because SU8 is a negative tone resist, the UV radiation initiates a cross-linking process in the resist. The post-exposure baking process done here ensures complete cross-linking of the irradiated areas. The uncross-linked areas can then be developed away in the SU8 developer, and then the entire substrate is washed in a DI water bath. After developing, the mold arrays can be inspected on a reflecting light microscope, and you can see the bar molds in the picture on the screen. Particle preparation. This is the attrition mill. It consists of a vessel down below and the attrition arm, which consists of 2 flat plates which spin inside the vessel. Our water plus dispersant, ammonium polyacrylate, is located in that container, and the amount of powder we're going to add is located in those 2 containers. The milling media is 1 millimeter zirconia spheres, and we will now add everything into the milling vessel. First we add the milling media, and then we add the water plus dispersant, and then slowly add the powder. After the milling process is complete, we need to separate the milling media from the slurry, which we want to keep. To do this, we use a centrifuge with filtration cups. What I'm doing now is adding the media plus slurry into one of the filtration cups. They're then placed into the centrifuge, and the filtration process begins. Afterwards, we need to scoop the good powder out of the bottom of the cups, and this is the powder that we're going to keep. You can see the consistency of our final powder is very thick at 50 volume%. A polymer matrix is created in the suspension prior to drying to increase the strength of the green body. To do this, a monomer and a crosslinker is added to the suspension, and gelation is initiated chemically. The initiator solution is prepared separately and formulated to allow us approximately 1 hour working time after initiation. Here, the gel constituents of monomer and crosslinker are added to our suspension, and the suspension and monomer and crosslinker are mixed on a vortex mixer to ensure uniformity. Also, during mixing 3 millimeter milling media is added to the suspension just to ensure uniformity as well. Just prior to casting here, the gel is initiated chemically with our initiator solution, and once again everything is mixed on the vortex mixer to ensure uniformity. Colloid deposition. Just prior to casting, our suspension has been initiated, and casting takes place in 100% relative humidity air, which is controlled inside this humidity cabinet which I'm working in. The suspension is taken out and placed on top of the mold, and then using a 90-degree squeegee with multiple passes along the length of the mold, the suspension is infiltrated into the cavities. After infiltration, the entire mold is taken and placed in 100% relative humidity nitrogen to allow gelation prior to drying. The nitrogen is needed to ensure there is no spallation on the surface of the gelled green body. After drying of our parts, they are placed into a furnace for the sintering process. During this process, the mold and the gel matrix completely burn away, and the particles sinter together, forming a dense ceramic body. Here I'm placing the substrate into the furnace and raising it up into the part where the heating elements are. We use a maximum temperature of 1300 degrees Celsius, and here is where we set the temperature profile. We employ soaks at around 400 degrees to help with the polymer burnout process. Here you can see the final sintered part on the left and the initial mold on the right, and the yellow mold is completely burned away. After firing, the sintered parts sitting on top of the substrate are washed using an ethanol spray bottle. The parts and debris are washed together into a falcon cup, and then the parts and debris are filtered through a screen, with the debris falling through the screen and the parts being left on top. These parts can then be manipulated for mechanical testing and also placed on SEM stubs for imaging.